Before we go back to where we left off on the last video, I realized that I had you highlight these as tests, but I didn't tell you which one they were on the practice test, because I like these to help you do your practice test. So back on page 1, letter C we highlighted, and that's number 1 on the test, practice test. And notice your practice test is I have it 2 places on your Canvas homepage, but if you printed out these notes, which I assume you did, your practice test is there with those. Okay. And I just want to remind you that it's super, super important that you guys do your Connect Math every night after you do your video notes, because our tests are now going to be on Connect or Alex, depending on what class you're in. And if you don't do your homework, you're not going to recognize the problems or know how Alex or Connect wants them written. So super important the rest of this class that you work on your homework, because that's where I'm going to make the tests, is from your homework problems. Okay. So everybody get these 3 down. So F is number 5 and D is number 6. C is number 1. That way, when you're doing your practice test in another week, you'll have a guide there. Okay, so let's go back to where we left off. We were factoring this. It looks a little bit ugly, but I'm going to show you a really cool trick of the trade that you're just going to love. So do your signs like you always do. This says the signs are the same. This says they're both positive. So put in your x plus, x plus. And so now you're probably thinking, how am I going to find factors of 49/4 that add to 7? Well, this is the trick. The square root of this goes in both the first slots. This is the sign that you're going to use in both. And the square root of this is what goes in both the second slots. So you probably didn't even realize it, but if you took the square root of x squared, you get x. You brought down this sign. If you take the square root of 25, you get 5. So you didn't even realize you're doing it, but that's the pattern. So take the square root of x squared. That's where those 2 x's came from. Use that sign. See how they're both minus? Take the square root of the last term. There's the 6's. I mean, I would factor on whole numbers because you need to be a really great factor for this chapter and for the final. So, but when they come to fractions and they're really ugly like this, it's nice to know that little shortcut. So square root of the first term, that goes in both the first slots. Whatever sign's there goes in both the signs, and then square root of the last. So square root of 49 is 7. Square root of 4 is 2. So that is my answer. X plus 7/2 squared. Isn't that a super nice trick? I remember loving that when my professor showed me in college, going, whoa, because, I was sitting there trying to figure out 49/4. Well, that's this times this, or, that's really hard to do. So nice little trick there. And if you've made it a perfect square trinomial, which we have by doing this process, that should always work. Okay, so now we're getting even busier, but guess what? Doesn't matter. We have a calculator. Our calculator does all the work. We just have to write it here correctly, and then we'll type it in the calculator. So half of b is 5/4, and then we square it. And remember, you want it as a fraction, so make sure that you use the fraction keys when you're typing them in. So type it exactly like you see it. So parentheses, 1, fraction bar 2, times 5, fraction bar 4. Close the parentheses, hit the x squared. So you type it in so it looks identical to what you have written down. Ooh, so they gave us a decimal just because it's ugly. But remember this key right here, F to D, and it also goes D to F, so we can go second, fraction to decimal, or in this case, decimal to fraction. Ding, ding, ding. It did it. So 25/64 is what you get. And these are pretty easy to do in your head too. 5/8 and then square it. 5 squared 25, 8 squared 64. So even if you forgot how to do it on your calculator, you just multiply straight across and then square the numerator, square the denominator. So that's my n value, 25/64. So now we're ready to factor. So our polynomial is x squared plus 5/4 x plus 25/64. So let's use our new fun little factoring pattern. Yay! So we have parentheses, and the square root of the first term is what goes in both the first slots. So the square root of x squared is x and x. This sign is what goes in both parentheses. So plus and plus. And remember, this little shortcut cutesy thing only works for perfect square trinomials. Don't start trying to do it on all the other ones. It doesn't work. It's because of this process that it works. So I don't want you to get too excited and think you found this brand new way to factor, because it only works on like maybe 0.1% of the population, and it's because we did this process. Square root of 25/64 so it'd be 5/8. So 5/8 goes here and 5/8 goes here. So my answer is going to be x plus 5/8 squared. And that's the hardest part of completing the square. After you do that, it's just square root property. So if you have this down and you feel comfortable with it, completing the square will be a piece of cake. I am going to tell you, this is probably the hardest thing we learn in this chapter. So you definitely want to make sure and spend some time on 7.1. Definitely. Okay, so this is the steps we're going to follow to do, I think it's 4 problems on the next page. 1, 2, 3, 4. Yeah, 4 problems on the next 2 pages. So if there is a number in front of the x squared, we have to divide every single term by that number. All the ones we had here had a 1, so we didn't have to do that process. But if there is a number in front, which I think we're going to have a couple of them today, then you have to divide every term. Divide by a, divide by a, divide by a, divide by a, because we have to have that be 1, and that's how we make it 1, by dividing by it. Then we isolate the terms with the variables on the left side of the equation. So everything that has a variable in it is on the left side of the equation. So that means anything without a variable, like the constant, goes over to the right. Then we complete the square by adding the square of 1/2 of the linear term to both sides. That's what we were practicing on up here. Factor the resulting perfect square. That's what we were practicing on right there. Then we do the square root property, which is what we did on the front page of these notes. So the last step is always to do this, square root property. Square root both sides, add a plus or minus, blah, 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 blah. Okay, so you ready to tackle one of these? I got an example first for us to go through. The example is like one of the hardest ones you'll ever see. Probably not something I would put on a 120 test, but they would not hesitate in your next class to put it on their tests. Definitely. So I just want you to be aware. I'm probably going to give you, I have it highlighted here, number 4, just a nice simple one, no numbers in front, just doing the stuff we did. This is number 2 on the test. But you will see ones like this in the next class and on your homework. So I put a hard one here so we could work through it together. So step 1 from the last page was, I'm going to bring that out. From the last page was divide to make your leading coefficient 1. So divide by 2, divide by 2, divide by 2, divide by 2. So here's what it would look like. So that turns into 1x squared, which is what we need. minus 5 halves x minus 7 halves equals 0 divided by anything 0. Step 2 says put the variable terms on the left and the coefficient on the constant on the right. So only variables on the left, anything without a variable to the right. So I look here and I go, well, this has a variable, but this doesn't. So I need to add 7 halves to move it over to the other side of the equation. So my new problem is x squared minus 5 halves x. And I make students write this plus blank equals 7 halves plus blank. So why do I make you do that? Because the next step says apply the square root, or that 1/2 of the linear term squared, to both sides. And the reason, if I'm going to add it to the left side, I have to add it to the right side, because otherwise the equation will be unbalanced. So I need it to be balanced, so I always write the plus blank plus blank. And then I have students say, well, how do you know it's going to be positive? Well, anytime you square something, it always comes out positive. Square something, comes out positive. Square a negative number, it still comes out positive. Square a negative number, it still comes out positive. So when we apply 1/2 of b squared, the answer will always be positive because of the squared. Anything times itself comes out positive. Any real number, I should say. Okay, so this is where we apply what we were just doing. You do half of the linear coefficient, so half of negative 5 halves would be negative 5 fourths, and then we square it. Negative times a negative, positive. 5 squared, 25. 4 squared, 16. So half of, I kind of like to do it all in one step like this, so you don't see something different. So half of whatever the linear term is. And then you can either do this on your calculator or in your head. It's pretty easy to do in your head. A positive times a negative is negative. 1 times 5 is 5. 2 times 2 is 4. And then we square it. Negative times a negative, positive. 5 times 5, 25. 4 times 4, 16. So now we have to add that into our two blanks. Because remember, whatever we do to the left side of the equation, we have to do to the right side of the equation. So here's our new left side. On the right side, we need to use our calculator. So let's just write that here. Use calculator to add. Because students go, how did they go from there to there? Because they don't show the work. Well, they're using a calculator too, probably. So 7 fraction bar 2 plus 25. What is that? Fraction bar 16. And remember, we don't want mixed numbers, so we do second AB over C, and we get 81/16. So that's how they got that to come out to 81/16. Okay, so here's our new problem. We have the square completed over here. This is what we just did 4 problems of on the other page, and then we have it set equal to this. So they applied that little shortcut cutesy thing I showed you. Square root of x squared is x. Bring over the negative sign. Square root of 25/16 is 5 fourths. And we know it's going to be that times itself, so I just went straight to that step. So that's the new stuff. This is what we did on page 1. Now that we have a squared quantity equals a number, to undo the square, remember we have to square root both sides. So these cancel each other out, and I get x minus 5 fourths equals, because I did the square root of both sides, remember how I have to do plus or minus, and then square root of 81/16, which would be 9 fourths. So then add your 5 fourths over. And I always like to put it in front of the plus sign. And you get 5 fourths plus or minus 9